Hi everyone, I'm William from mathtuition88.com, and today we are going to discuss a rare proof that square root 2 is irrational. For the usual proof by contradiction, please check out the link that I have provided below. And furthermore, if you want to speed up the video, remember that you can always select the speed at the bottom right hand corner of the YouTube settings. So let's start. So first we have to prove that square root 2 is never a over b. It can never be expressed as a fraction a over b. This a over b is a rational number. If we prove this, then we have proven that square root 2 is irrational. So let's begin the proof. It's a bit longer than the usual proof. So first we consider the difference between square root 2 minus ab. First we can make it into a same denominator over b. This will be square root b minus a. Next we will rationalize the denominator. How to do this? We will multiply by the conjugate as follows. We will multiply by root 2b plus a over root 2b plus a. Okay, this will actually rationalize the numerator. Let's see what happens to the fraction. Okay, the fraction on the top, using the identity, here we need to use this identity, a minus b, a plus b equals to a squared minus b squared. Okay, this is just a side note to explain how we derive at the final answer. So the top will actually become 2b squared minus a squared, if we think about it, and the bottom will become square root 2b squared plus ab, and this will become, if we factorize out the b on the denominator, it will become this, root 2b plus a. Okay, this will be one of the important formulas. So please remember this formula. Okay, I'll copy the formula on the left, and we will continue. So what we have proven currently is that square root 2 minus a over b equals to root 2b squared minus a squared. Okay, so yeah, thanks for following me until this moment. Okay, now we will do some analysis of the numerator and the denominator. First, we will try to factorize b and a. Okay, so let's take a look at a first. We can we can attempt to write a as 2 to the power of alpha multiplied by x, where x is odd. We basically take out all the powers of 2, leaving behind an odd factor. We can always do this for any number. For example, if a is 18, we can say A is 18 is 2 times 9. If we are looking at 12, we can say is 2 squared times 3. Okay, similarly we will write 2 is 2 to the power of beta times y, where y is odd. Okay, then 2b squared will be equals to 2 beta. Okay, 2b squared will be actually, if we look at it, it will be actually 2 beta plus 1 times y squared. Yeah, we can work it out slowly, and we can arrive at this conclusion. Because b is already 2 beta times y, so b squared is 2 to the power of 2 beta times y squared multiplied by 2. That's how we get the plus 1 over here. And a squared is actually 2 to the power of 2 alpha times x squared. Okay, so we can conclude that 2 beta squared is never a squared, since the largest power of 2 dividing 2b squared is actually odd. B squared is 2 to the power of 2 beta plus 1, which is odd power, while the power of 2 dividing a squared is actually even, 2 alpha, so they are not the same. So we can conclude that hence 2 beta squared minus alpha squared is always greater than equals to 1. Okay, this is also quite important, so we can write it as a note here. We have proven that 2 beta squared minus a squared is always greater than equals to 1. We have finished analyzing the numerator. Now it's time to analyze the denominator. Okay, so let's look at the denominator, and we are almost done. Okay, so let me erase this quickly. Okay, now let's look at the denominator. Okay, first we have to have a bound. We have to look at a bound for a over b. A over b, we can have this upper bound for a over b. Okay, because a over b is definitely less than equals to 3 minus root 2. Since if a over b is greater than 1.59, there's no chance that it is equals to root 2, which is around 1.41. So we can safely assume this inequality. Okay, then rearranging the above this inequality, we have root 2 plus a over b is less than equals to 3. And multiplying by b, we have root 2b plus a less than 3b. Okay, now we are very close, so please stay tuned. 2b squared minus a squared over b root 2b plus a will be greater than, okay, recall that the numerator is always greater than 1, so we can put here 1, and the denominator is this part, we can put 3b, because the greater the denominator, the smaller the fraction will be, which is 1 over 3b squared, which is greater than 0. Hence, the difference between root 2 and a over b is always greater than 0, strictly greater. This means that root 2 is irrational. We have completed our constructive proof of the irrationality of root 2. Thanks for watching, and please subscribe to our channel.